Hi everyone. In our last lecture, we talked about structs. In this lecture, we are going to learn about another very popular data type, which is enums. Enums, short for enumerations, are a powerful feature in Rust that allows you to represent multiple related values within a single data type. Enums are particularly useful when you have a set of distinct values that need to be treated as a coherent group. In this section, we will introduce enums and show how to define and use them in Rust. Imagine if you are building an application that involves different types of weather. You could represent the various weather conditions using individual string or integer values, but this would be error-prone and difficult to manage. Enums provide a more elegant solution by allowing you to define a custom type that groups all possible weather conditions together. So let's create an example about this weather and see how enums work. To create enums, we are going to use the enum keyword here, and then we will say weather. Here we have different types of weather. First we have sunny, cloudy, rainy, and finally snowy. And let's create an instance of this. We are going to say let current weather equals weather sunny. So what we did is from the weather enum, we get the sunny variant and we put this into the current weather variable. So if you realize that's how we were using strings, and we were saying string from, and we were creating our strings through string slice references. And for that, we are actually using methods like we used in structs. And for that, we were accessing them through double columns here. We also use the same ideology in this example. We are saying whether, like we are getting a from function from a string, but here we are getting the sunny variant. We will use this annotation to get the variations of the enums. As you can see, it's a kind of useful way to group them together, so it's easier to understand and use. But that's not all the enums do. Enums can also have associated data types they carry. So let's create an example and see. Let's create an enum called message here. And here our first message will be quit. Next, we have a message called move. And here we have some data. We say we have X here and it's I32, and also we have Y here, which is also I32. And then we have write. This write has a string. And finally we have change color, which holds a tuple, and we are going to say I32 here. So as you can see, we have multiple data that we are carrying here. Before we were saying sunny, cloudy, rainy, or snowy, just the name of the variant. Here the variants other than the quit are actually holding data with them. And now we are going to see how we can create the instance of it and how we can use these values that we are carrying. First, let's create the instance. I'm going to say that message equals message write, and here we are going to say string from. Let's do something different here and say hello Rust instead of world. I know I'm getting too creative here. So this is how we create the instance. So it's the same ideology. We put the name of the enum, then after this double semicolons we have the name of the variant. This didn't have any value associated with it, but here we have some value, and this value is string, and we put a string here which is hello Rust. Now let's see how we can use this enum that we created, and best way to see how this works, how we can do something meaningful with this kind of enums, is to use them together with match statements. So if I create a function below, let's say function process message, and here I will have a message as the parameter and the message as the type. Inside this I'm going to say match message, and for the first arm we are going to say message quit. So we are checking if the message is quit variant under the message enumeration, and if it is, we are going to say println the quit variant has no data. Let's see for the next one. We are going to say message move, and with move we have data associated with it. For that we are going to say X and Y here, and then we open our block. Inside this block we are going to say println, and we will say move to coordinates X and Y. Let's do it like this. Then I will say X and Y. So this x and y comes from this move. This move has a data associated with it, and if the message that we are passing have this associated data, then we are going to use this data from the move. With the same ideology, we are going to create one for the right. Here we say right, and we will say text. So we can say any name here. It doesn't have to be a specific name. But once we put the variable name here, we need to use the same name. We are going to create our block here, and we will say println text message, and this will be our message. And for the final one, let's say message change color, and let's say RGB. If any of you coming from front end, I think you are used to this RGB and all this color tuple. Here we will say println change the color to red, green, and blue. Then we are going to say RGB. So let's run this function and see how it works. I'm going to say process message here, and then I'm going to pass this message. So our message is the type of write, and the string we have is hello Rust. Once our function run, then our match statement will be executed, and it's going to check its first match arm. If the parameter that we are passing is either the quit variant of the message enum, since it's not, we are going to move, and we will look if our variant is move of this enum. It's not, we said it's right, and then we go to the next match arm, and here we have the right. So this is the code that we're expecting it to be executed, and whatever value that we are carrying with this right variant, we are going to print out. And also, if you notice, in our earlier match statement, we had to put an underscore here because we were using i32, which can have multiple values, and we were just checking a couple of them. But here we have an enum which has 4 different variants, and in this match statement we have 4 different variants. So if the type of the data we are passing is message enum, then there is 4 scenarios that can occur since we have 4 variants. And since we are checking all the variants here, Rust is not complaining about unchecked possibilities. So what we are expecting it to print is that it's going to say hello Rust, and let's see if that's the case. First, let's build our project. I'm going to say cargo build. Next, we will say cargo run. And as you can see, our text message is hello Rust. If we say something different and anything other than some sentence starting with hello, and if we run this again, you can see that we just printed out our new value. And that's the way how we can extract the values from this enums. One of the ways is to use this match statement, and this is one of the best way to use it. We also have another syntax, so let's create another enum to see that. Here I'm going to create an animal enum, and inside here I will have dog, it will hold a string. I will have cat, which also holds a string. And I have a bird, and guess what? It also holds a string. Alright, now let's go to our main function. Here I'm going to create my pet, which is a cat. We will say animal cat, and the name of my cat is Melo, and say to string, since we are expecting string here. And then I'm going to say if let animal cat name equals my pet, then we will have our block here. So let's see what's happening here. What we are saying is try to execute this part. So if this is executable, then move to here. On the left hand side, if we see, we have animal, which is a cat, and we are carrying the name. On the right hand side, what we have is my pet, so which is an animal. This is also a cat, so this adds up, and then the name is Melo, and here the name is just waiting for it to be filled. So if the left side is equal to right side, which we can equalize them, since they are the same variant of the same enum, this name here will become Melo, because since they can match, we are just putting the result of this expression here, so our name can be Melo, which is another extraction method. And here I will say println my cat name is, and then the name. If not, we are going to say else, println my pet is not a cat. So let's execute and see if it works. As you can see, it says my cat name is Melo, and as we talk, once we said if let animal cat name equals my pet, we are saying let's see if we can say this is equal to this. So if we are able to make this assignment from my pet to this animal cat, then we will be able to execute this line here, and then we are going to extract the name, which is Melo in this case, since we assigned my pet to this animal name. If there is something wrong, then it's going to say my pet is not a cat. So this is another extraction method we can use if we are just checking one variant instead of multiple variants like we did here with this function. Here we are checking multiple variants and saying I'm going to do this in this case, I'm going to do this in that case. But here we are just saying I'm going to do something if it's just one case. For any other case, I don't care. For that, we don't need to have a match statement. It's better to use if-let statement like this here. Now, let's see how we can implement methods for enums like we did for structs. Down here, I'm going to say implement message. So as you can see, this is the same way that we did for the structs. And under this, I'm going to create a method, and as a parameter, it's going to take self. And in our previous lesson, we talked what this self is. This self refers to the instance that is calling this function. Then we are going to say match self. So we are checking which variant from the enum is calling this function. If the variant is message quit, then we say println quit. We put comma here, then we say message move. If the variant of the message is move, and we should also say x and y here, then we are going to say println move to x, and we will say x and y here. For the next one, we will say message write, let's say s, and here we will say println write, and we will say s. For the last one, we have changed color, and we will say RGB like we said before, and here we will say println change color to R this, and for the G, so with the second one, for the B, which is the last one, and we will say RGB here, and that should be exclamation mark. It's not a comma. Alright, so let's see what we did. If you remember from the struct, we had the same ideology. We have a separate structure here, and we have a separate structure to implement the methods for that one. So we have our enum message here, and then we have another implementation block where we are implementing methods for our enum message. Here, our method name is called. It's taking only one parameter, which is the self, and this is the instance that is calling this function. One of the variant of the enum is going to call this function, and for that we are using self. To understand which variant is calling, we are matching self, and here we are doing a very similar thing like we did here. And let's use and see how this works. Up here, I'm going to say that message equals message write string from Melo is sleeping. He does that a lot. And then we are going to say message.call. So with this call function, we are calling this method that we associated with our enum here, and the variant that is calling this function is the right variant under message enum, and for the string we pass Melo is sleeping. So what we are expecting it to happen once we call this function, our match statement is going to execute, and it's going to match the self. And in this case, self is right variant, and then it's going to execute this match arm. And in this match arm, we are going to extract this string here, and we are going to print out saying write and the string. And for us, the string is Melo is sleeping, so what we're expecting it to write is to write Melo sleeping. As you can see, it says write Melo is sleeping. So that's how we can use methods with enums. That's all for this lesson. Thank you very much, and I will see you on the next one.